Hello, my name is Brian Cooper, and I am showcasing my engineering design process for the periscope that I made. Not sure if you can see it. I know the lighting is pretty bad, but let me go over what I did. Okay, so uh, I followed the engineering design process as directed, and so first thing we had to do was define, and we've all read this, and so we need to define the problem. The problem is, how can I see above the crowd without standing on top of anything? And I ask, how can I see above the crowd without standing on top of anything? Same thing. A possible solution is to use a periscope. And so after that, I had a plan. And so first I looked at a diagram of how a periscope worked. And looking at this diagram, you can see that the periscope is shaped like an S. The mirrors inside are at 45-degree angles to reflect the light downward and then across in order for the light to reach the eye in order to see above. So there is a two-mirror process. One mirror reflects off the other. The light travels down the periscope and bounces off the mirror at the bottom. I then gathered the materials required in the periscope plans that were provided. Materials I had were scissors, mirrors, cardboard, pencil, masking tape, double-sided tape, a T-square, which I use as a ruler for accurate and precise measuring, and strong tape, which I use clear packaging tape. So I followed the directions by first cutting out the cardboard based on the dimensions given in the directions. So I saw my cardboard and I said, okay, got to cut 20 inches across and 9 inches down. And at that moment, I did not realize until I was done and moving further into the directions where I had to measure these subparts in the middle that there were some inaccuracies in the directions because 2.5 plus 2 plus 2.5 plus 2 equals 9 doesn't really give you leeway for that 3/4 of an inch down here that you would use as a tab for later on in the construction of the periscope. So I looked ahead in the directions and I figured maybe I did not need that tab, and so then I no longer had a use for the double-sided tape. So I began cutting and following the directions and cut out my triangles, and this is what I got. And I noticed that when I tape the triangles in the end to give it that bent shape, the masking tape wasn't enough for it to be stable. So I double-sided, so I put tape on both sides, on the inside and the outside, for better security. And then when I put the mirrors on, I used the packaging tape to put it on. I noticed that there were some gaps in between. And so I thought, okay, so what materials do I have that I can use? I have this masking tape that I can use. And I thought, okay, it's pretty opaque enough for light not to shine through. So I used that to cover up the gaps. And in the end, as you can see in my work area, I came up with my periscope. And it works pretty well. I can definitely see above my head. So how would I improve? Well, when making marks using a pencil to indicate where to cut, and measure giving the dimensions, I would measure giving the dimensions an extra 1/16 of an inch to prevent any open gaps like you saw before. Another way I could improve it was I could learn how to use a 3D printer and make the periscope out of plastic so it could be weatherproof or more durable. And even though I said that the masking tape was opaque, it actually is not really opaque. It is translucent, where some light still shines through. So maybe, like the directions said, I could paint the periscope to prevent any light from shining through the translucent tape. Thank you so much for watching. I hope you enjoyed.